Alright, hey guys. Today we're going to go into section 1.2, which is measuring and constructing segments. Your objective is I will be able to use length and midpoint of a segment to solve problems. So we're going to be using distance formula and some midpoint. So distance formula. You probably learned it with some x's and some y's thrown in here, right? I like to teach it as the shell. So if you understand this shell, you put your x coordinates in one, you put your y coordinates in the other. The actual formula was y2 minus y1, x2 minus x1. But like I said, if you just understand to put your y's in one of them and your x's in the other, you should be fine. So we're actually going to start with that formula. So something squared plus something squared. We want to take the square root and subtraction. So there's my shell. Now here, notice it just says find AB. So this is actually the distance from A to B. That's what this stands for. So geometry is a lot of shorthand, and you have to understand what they're asking for sometimes. So here, find AB means find out how long from A to B. Find out the distance. So we have some coordinates. We're going to find our x coordinates. And again, you can write 3 minus 0, 0 minus 3. It does not matter because once you square it, everything's going to be positive anyway. So I like to make it easier on myself. I'm going to say 3 minus 0. Again, just to make it easier on yourself. Here you have a negative 8 and a 2, sorry. So again, I'll just keep them in the same order, negative 8 minus 2. And then we're going to do some math. So here, 3 minus nothing is 3. Squared is 9. Right? 3 times 3 is 9. Negative 8 minus 2 more makes negative 10. Squared gets us 100. Now it does say, so we're going to go ahead and add square root of 109. It does say it wants an exact answer. Exact means they do not want you to round. So when you type this in the calculator, square root of 109, you're going to get 10 point something. Let's see. 10.440306, right? So we don't want to do that. We're going to actually stop that as an exact answer, the square root of 109. All right, moving on. Segment addition postulate, you will use this a lot. All it's saying is that the pieces add up to the whole. So this says if B is between A and C, so B is somewhere in between, then AB plus BC equals AC. This piece plus this piece makes up the whole thing, AC. So look at the example. They tell you the whole thing is 31. So 10 and what make 31? Well, that means x has to be 21. Right? 10 plus 21 makes 31. You could also set up an equation if you're into setting up algebraic equations. You know the pieces should add up to the whole. So 10 plus x, right, the pieces, 10 plus x, should add up to equal 31. And then you could subtract 10 from both sides, and you get x equals 21. Now, the reason I wanted to kind of show you, logic and actual algebra is because sometimes it's not going to be this obvious. So I want to make sure that we're good with this. Which brings us to the next example. This one's not as obvious. Something plus something equals 6x. It's not as easy. It's not as intuitive as the last one. So we're going to actually use algebra on this one. We're going to say our pieces add up to equal the whole. So our pieces, 3x minus 1, add up plus 13. So our two pieces should add up to equal the whole thing, which they're telling us is 6x. Now, to be honest, that is the only geometry in this problem, is knowing the segment addition postulate. The pieces add up to the whole. Everything after this is algebra, which is why we did a little bit of algebra review yesterday. Or the day before, sorry. So here we have 3x We're going to combine like terms. So we have a negative 1 plus 13. So we're going to have plus 12, right? 13 minus 1 is 12. We're going to combine like terms. Now we want to get our x's to one side of our equal sign, so we're going to subtract 3x from both sides. Here we've got 12 equals 3x. And we want to get x alone, so we're going to divide both sides by 3. Now, geometry is infamous for this. 4 is not the answer. Make sure you read. This is what gets people in trouble. Make sure you read. If this was multiple choice, I guarantee 4 is in your answer choices, and I guarantee somebody will pick it, so be careful. Make sure you read the question. They want you to find DE. So we come back here, D to E, right? DE is 3x minus 1. So now we know x is 4. We're going to substitute 3 times 4 minus 1. So 3 times 4 is 12, minus 1 gets me 11. That is your final answer, so be super careful. 4 was not your answer, but it's getting us to the answer. You can also go back if you're ever feeling unsure, right? I don't know if my answer, I don't know if the 4 was right to begin with. Plug everything in and check it out, right? Make sure that the pieces add up to the whole. We said 3 times 4 is 12, minus 1 was 11. And then 6 times 4, because it's the same x, 6 times 4 is 24. Does 11 plus 13 equal 24? It sure does. My answer was correct. So you can always reassure yourself if you plug it in and make sure that the pieces add up to the whole. So that was our segment addition postulate, adding segments. Midpoint. So the midpoint of a segment separates the segment into two congruent segments. So here, if they tell me P is a midpoint, we know that NP is equal to PQ. So if this is in the middle, you know these two pieces are equal. And notice how I put tick marks on here. So a tick mark tells you that these two pieces are equal. You might also see 2 tick marks. It's the same thing. If this one has 2 tick marks and this one has 2 tick marks, then they're equal. Okay, so you're going to start seeing symbols in geometry. I just want you to get used to them. So again, because of the word midpoint, I know P is the midpoint. I know these two pieces are equal. So if they're equal in algebra, then we set them equal. So 3x has to equal 2x plus 4. Totally didn't do the question. Number 13, sorry. PQ is congruent to, so PQ is congruent to NP. Line segment NP. Or PN. You could have said PN as well. Now it says, what is the value of x? So again, if they're equal, set them equal. We want to get our x's over to one side, so that's a positive 2x. I'm going to subtract 2x from both sides of our equal sign. So here, 3x's minus 2x's leaves me with 1x and 4. So x equals 4. And this wants you to find everything. Now, to be honest, if you know they're equal, you shouldn't have to plug into everything. So let's plug into NP. That one looks the easiest. NP is just 3x, right? So 3 times 4. 3 times 4 gets me 12. So I know NP is 12, which means PQ is 12. And then 12 plus 12 gives me that NQ is 24. So NP is 12, PQ is 12, and then NQ was 12 plus 12 was 24. So the pieces add up to the whole still. Bisect. So bisect kind of goes hand in hand with midpoint. A midpoint does bisect. So it cuts a line segment into 2 equal pieces. So you can bisect angles, you can bisect segments. So let's read this. Point S bisects line segment RT. So let's draw a picture. I don't see a picture. So we have a line segment RT. R to T. And we know point S is bisecting, which means it's cutting it into two equal pieces. So again, those tick marks mean that those are two equal pieces. And then let's label our stuff. So RT is negative 2x. ST is negative 3x minus 2. Well, if ST is negative 3x minus 2, RX should be the same thing, right? So we have negative 3x minus 2 over here as well. They're equal because of that word bisect. And we know our segment addition postulate. The pieces should add up to the whole. So the pieces, negative 3x minus 2 plus negative 3x minus 2, the pieces should add up to equal the whole thing. We got a lot of like terms to start combining. So negative 3x and negative 3x makes negative 6x. Negative 2 and negative 2 makes negative 4. Now let's get our x's to one side, so let's add 6x to both sides. So 6x's minus 2x's leaves me with 4x, and divide both sides by 4. So x equals negative 1. Again, not my answer. Not my answer. They want us to find RS, ST, and RT. And again, you should only have to find one. So let's start with RS. Negative 3x minus 2. So negative 3x was negative 1 minus 2. Negative times a negative is a positive. And we get 1. So if RS is 1, then ST is 1. And RT is 1 plus 1 is 2. So we got 1, 1, and then the whole thing is 1 plus 1 is 2. So that kind of used a lot. That used bisecting, and that used segment addition postulate. So understand what pieces are equal. When you hear the word bisect, what pieces do you know are equal? When you hear the word midpoint, what pieces do you know are equal? There's your homework, and the textbook page should be uploaded to Focus. Should be uploaded to Google Classroom. Upload your assignment with all work shown. So see all that lovely work I'm showing? Okay, you're not doing this in your head. Make sure you show the work. If you have no work shown, I'm not giving you credit. So make sure all work is shown. And upload it to Focus when you're done. Bye, guys.